statistician and independent statistician. The trial statistician is involved in the trial from the beginning to the end of the study, right? While independent statistician is responsible for generating the blinded codes, and that has to be from the different institute. And the biostatistical center, if you are doing some multi-centric study, so it is always good to involve one statistician who can manage even data from each center, and we can have collective data, a very good quality data, because when you are using any statistics and you don't have the good quality data, it is really difficult for anyone to produce a good evidence. So we have to have a good quality data for conducting. What is happening in India, we have the gold mine of data, gold mine, like number of things we can collect, very good quality of data. But what is happening here, we are not properly managing our data. Like, data management is very important, otherwise we can produce very strong evidence for our research studies. Now let's start our presentation. I hope that you people have been like seeing in this workshop what is the difference between differences and relationship between the variables. So I'm directly coming from the point, but I generally want to discuss from the starting that what type of data, if you have gone through this, but though we cannot interact too much because of the large number of participants, what we can do,
Ma'am, you can, if possible,
we
you can,
can,
yeah, we can video, you can
yeah,
stop the
I was
video so that,
thinking on that.
yeah, so
Huh.
that the bandwidth
That
will,
will be easy, and
yes,
network will also be good.
yes, yes.
Yeah. So, yeah. So what is happening here? We have already talked about the two things, differences and relationship. If you are analyzing more than two variables together, two or more than two variables, if you are analyzing one variable, what it is called? A descriptive statistics or univariate statistics, where you are analyzing one variable at one time point, and what you can generate only descriptive statistics. When you require to compare two things, then you can find, or you have to find out when you have to, like, what is your objective, to find out the differences between the two groups, or two variables, or the relationship between two variables. Okay, so what is happening here, when my objective says I am examining differences between groups, okay, groups means variables or different types of, then what we have to do, we have to apply t-test and ANOVA. I hope you have already exposed to these two type of statistical methods. Now, if our objective is to examine the relationship between two variables, then what we have to do, we have to apply correlation regression. Now, why I am writing here only correlation regression, one more statistical method can come here. Can anybody tell me what statistical method come here? Because my topic is on correlation and regression, that's how I am writing it here. When your objective is to find out relationship between the variables, what else other method can come here? Quickly, I need 2-3 answers. Factor analysis, no. Chi-square, somebody is writing chi-square. Exactly. Now, if chi-square is the correct answer for this, so examining the relationship between the variables. Now the question is whether you have to use correlation or chi-square. What is the criteria when you have to use correlation and when you have to use chi-square? So as you have gone through the different types of variable, we generally divide our variable into two parts. One is numeric, another is categorical, right? So if you want to assess, you want to find out relationship between two categorical variable, then you have to use chi-square test. Now here we will be talking about two continuous variables. Okay, so what continuous variables? Continuous variables means where we have measurement unit. Yes, exactly. People are writing height, weight, numeric, where we have measurement unit to measure it. Where we don't have measurement unit, but it is really important to take into our research like pain. Okay, so pain we cannot measure with some instrument or some measurement unit. We don't have kilograms and liters, but it is very important as an outcome if I am giving some medication or something. So categorically we can take into account, we can define pain as a mild, moderate, and severe. So we cannot measure it in the kilograms and liters, but we can define that particular variable in what terms? Category, in terms of category, attributes. Okay, so what we have to do, let's say we want to see whether a different kind of pain between the gender and pain, we want to see the association. Back pain, let's say, who's having more? So is there any association between gender and pain? Let's say back pain or leg pain, whatever you want to categorize, then pain will be having three categories: mild, moderate, and severe, and gender is having two categories. In that case, what we have to do, we have to find out the association between two categorical variable, and we have to apply chi-square, exactly said by Dr. Sojal Parker. Okay, so now we are not studying chi-square because we are not studying categorical variables. So specifically, categorically in statistics, it is defined. If you are defining association, that means association uh, has to be fine in two attributes. But when we are saying correlation, it has to be between two numeric variables, right? So two numeric variables, we will find out the correlation and regression. Now if you have both variables, now we are talking about two variables. Always think of two variables or more variables. You cannot talk now one variable, because we are talking about the relationship. When we are talking about relationship, we need to have two or more. Okay, so in correlation, what will happen, why I am writing both the methods together? So correlation and regression, what is the relationship between these two methods when we have to apply? So I can say in simple layman language, correlation is a bachelor degree and regression is a master degree, just to remember. So what is the difference, bachelor degree and master degree? You can do the bachelor degree, but to pursue master degree, you have to have the criteria of the bachelor degree. Until you have done your bachelor degree, you cannot go for the master degree, right? So once you have passed this exam of correlation, then you can think of regression. If your two variables have not passed this exam of correlation, you will not be able to apply regression method on these two variables. So first step is correlation, and then is the regression. So we'll go one by one like this. Okay, so let's start. Correlation. What is correlation? Is a finding relationship between two quantitative variable, as I have specified in the beginning, without being able to infer causal relationship. Now, what is causal relationship? Causal relationship means if you have two variables x and y, we can correlate and we can say these two variables are associated or correlated with each other. But cause effect relationship means you are saying because of x, y, this is happening in y, or because of x, this is happening in y, or vice versa. Okay, so that we will not able to do it. So correlation is, in the sense, it is a descriptive measure, in one of the kind of descriptive measure which is telling us about the correlation. Okay, only relationship. We cannot say because of this is happening. If you have to answer this because, then you have to apply regression technique that we are going to see today. So correlation is a statistical technique that is used to determine the degree to which two variables are related. So that means because we have two quantitative variables, we can quantify the relationship as well. between these two variables. They are strongly associated or strongly related to each other or not. So basically with the correlation we can find out two things. One is nature, another is strength. Okay, so nature means they are positively associated or they are negatively associated. If I talk in terms of the simple thing that I am talking about, two-person, let's say, not variables, two-person, I am observing them, they are connected with each other. Now I want to find out whether they are friends, whether they are relative, or they are enemy, right? So nature, that means positive or negative, and strength means the degree by which you can say strongly as related, correlated, or a very weak relationship is there. So two things we are going to find out from the correlation, and that will tell you only descriptive thing that these two are strongly associated or weakly associated, and whether they are positively associated or negatively associated. But if you want to find out because of this is happening, then you have to apply regression technique. Yes, so now in linear regression, that is correlation coefficient is represented by small r. As you can see, it can be done through the scatter plot. Scatter plot between, you have to plot two quantitative variables on the different axes, x-axis and y-axis. So as you can see on the left hand side, strong relationship has been portrayed, and on the right hand side, weak relationship has been posted. So what is the difference between weak and how you can find out? Because this is we generally define it as a linear correlation. So it has to have some linear line, and all the data points has to be near to this particular line. If they are near to, and these two dash line represent 95% confidence interval. So if your confidence interval is narrow, you have the strong relationship your variables are having. While in the weak relationship, what is happening? You are having your data scattered all over the axis, and it is not near to this linear line. So this is weak relationship. So this is one of the way of representation of the relationship. But let's measure it. So what are the properties of correlation coefficient? You must know that correlation coefficient is the ratio of something, like it is covariances divided by variances. Okay, so this is a ratio of two variances, covariances divided by variances of x and y. So it has to be in between -1 to 1. So that is the criteria, that correlation will never go up from one of the either side, -1 to 1. Now interpretation of r, what it will be? So it will be like, we are going to see how to calculate it, right, in the hands-on session with the SPSS. So let us understand the concept and interpretation part. So these are the ranges which is defined, and different ranges are defined in different literature, maybe books and some other, but this is the thing which I like most, and that's how I am representing it here. So if you are finding correlation which is having 0.7, or you can say 70%, more than 70%, if two variables are related with each other, so we have to interpret that higher, very, this is like, if it is more than 70% or higher, we have to say very strong positive relationship, very strong positive relationship they are having. Okay, variable x and y. If they are in between 0.4 and 0.69, that means strong positive relationship. If it is between 0.3 and 0.39, that means moderate positive relationship, weak positive relationship. And when we are getting correlation 0.01 to 0.19, negligible relationship. And we will not recommend that if you are having this much of small relationship between two variables, you should not try to find out the cause effect relationship, or you should not try to do regression analysis for this. But there are some other criteria which we have to take into account, which we are going to take in our subsequent slides. And by chance, if you are getting 0, that means there is not at all any relationship between variable x and y, and they are independent of each other, then you can say. Okay. Now, what if we have negative values? So if we have negative values, similar interpretation will be there. Instead of positive, you have to just include negative, just like this. I am changing this. Okay. These things are there. Now, let's move to the, so this is about the correlation, how it is important. We are going to see in our hands-on session also. So let's start with the regression, which is the topic of today. This is a statistical technique for investigating and modeling the relationship between variables. So basically, if you want to define the regression, which is little catchy word for, not very catchy word for the simple person. So what you can say, regression, that means predictive modeling, or it's a prediction. We want to predict something with the help of independent variables. Okay. So regression is a statistical method that is used to determine the strength and characteristics of the relationship between two different types of variable x and y. But here in regression, we have to define what is your dependent variable and what is your independent variable. Now in correlation, x is related with y, with they will be associated or related with the same degree if we calculate x versus y or y versus x. The relationship will not change. But when we change the dependent variable and independent variable, the whole prediction and equation will change. So you have to define beforehand what you want to predict with the help of what. Okay. Let's say if I say, and you can say this linear relationship is defined by y is equal to a plus bx, which is equal to the equation of a line y is equal to mx plus c, which everybody has studied about in class 10th. Even they have studied biology afterwards. But yeah, this is the equation and this is the concept. This is earlier, it is started with the method of least square, and later on Francis Galton has introduced this method in biology in 1911. So let's understand what linear regression is and what are these coefficient a and b, what they are doing here. So as I told you, now we are analyzing two variables. Now you have to define what is your, let's say x and y are two variables. Okay. So they are from x and y, what is your dependent variable and what is your independent variable. Now let me talk about in terms of some examples. X and y and x and y, when we will say all the time, so what will happen, this looks like more mathematical. Now I have two variables, let's say height of a child. Okay, I am collecting information, height of a child and age of a child. Okay, child I am defining 0 to 2 years. Okay, so what I am collecting, two information, height of a child and age of a child. Now in this, what will be your dependent variable and what will be your independent variable? So you can write dv and iv in your chat box. Yeah, I'm getting a lot of answers. Dependent variable is height. Yes. Most of you are saying correctly right. That means you have got very good sessions. I can make out that. Why age cannot be dependent variable? Because we cannot predict age with the help of height. Here you have to think, you have to use, this is not a rocket science, you have to just think age is always independent factor, one thing. Second thing, that you cannot predict age of a person with the help of height, right? But you can predict the height with the help of age, specifically if you have a specific population, study population, as I mentioned, child, right? So what will be your regression? What will be your regression equation here? It will be height equal to a plus b height equal to a plus b into age. And what is this e term? E term is error term. Now this error term is what? This error term doesn't mean that you are making some error. You know, when we are doing prediction, we cannot do 100% prediction. Okay, we cannot do 100% prediction in this. So we cannot do 100% prediction, and that's how we have to incorporate some kind of error. What kind of error? So this is a statistical error which is defined in terms of residual and type 1 and type 2 error for hypothesis testing. So this error we have to take into account, and we cannot say 100% prediction is correct, but yeah, we are trying to reach as close as prediction we can do. So that error term we have to include, and we are calculating this error term in our model. And if you are saying this error is very less in our model, so you have to calculate this error term which is residual, and you have to say that we are introducing this prediction model with the very less error. Okay, so your model will be accepted by the scientific community. So we have to measure this error term. How? We are going to see in hands-on. So let's move to next slide. If there are different types of regression, if you have heard about linear regression, which we are going to talk today, and logistic regression. So two types of regression, because it itself, it is very very vast subject. We cannot cover it in 2 hours of the session, but yes, we are trying to cover as much as possible. So type of regression, what and how you can decide which type of regression you have to use for analyzing two variables, x and y. How you decide that what type of variable regression you have to apply for analyzing two variables x and y. You want to find out cause effect relationship between x and y. Now what type of regression you have to apply? What determines? What is a factor? There is a single factor. If you anybody can tell me. Exactly. Yogesh is saying dependent variable. Exactly. Okay. So what type of dependent variable you are having, that determines what type of regression you have to apply. Okay. So how? Your dependent variable is continuous. If your dependent variable is continuous, then you have to apply linear regression. Okay. If your dependent variable is dichotomous, okay, or categorical variable, then you have to apply logistic regression. If your dependent variable y is ordinal variable, then you have to apply multinomial logistic regression. If you are using dichotomous variable with some condition, let's say for case control study, matched case control study, there you have to apply logistic regression. Okay. And other than that, if your dependent variable is time variable, that means it is not just only you're recording the date. Time variable, that means duration. Let's say overall survival, progression-free survival, that kind of thing you want to predict. You want to predict the overall survival of a subject after treatment or after diagnosis or after some therapy, then you have to apply Cox proportional hazard regression. So it depends on y. Now, what is the criteria for polynomial nonlinear regression? So non-linear, again, you have to have your y as a continuous variable. But we have to see with the continuous variable, linear and non-linear, which one will go. So that there are some criteria, some assumption which we are going to see whether we have to apply linear or non-linear regression in our study. Okay. So this is clear. It depends on your dependent variable. which type of regression you have to apply. If you have a continuous dependent variable, you can apply linear or non-linear based on some assumption. If you have categorical dependent variable, let's say case control, treatment, placebo, or gender, then you have to apply logistic. And conditional logistic is for matched case control study design, okay, where you have matched pair of thing data. And if your y is time variable, that means duration, okay, for survival or some other thing which you are measuring for the duration. So this is the thing you can understand from this. Let's go to the linear regression and logistic regression. While we will be doing these two things hands on, then it will be more clear to you that why and what we are applying for. So dependent variable, if you want to understand, I have very good slide, next slide, on which you can see, because some people are writing explain it again. So here you can see. This is the complete model which I have taken from one book, that when you have to apply linear regression, when your description is the linear relationship and continuous variables, you are having continuous dependent variable like weight and blood pressure, okay. An independent variable can be of any type. It can be of any type. It doesn't matter independent variable, what type of independent variable you are having. For logistic, prediction of the probability, and you can have the dichotomous variable. That is very much required. Dichotomous, that means only having two categories, like yes and no, case and control, treatment and placebo, that kind of. Only dichotomous or binary variable, you can say, only having two categories. And again, for all kind of regression, independent variable can be of any type, okay. But dependent variable determines the type of regression. Now proportion hazard model, that is survival time, time from the diagnosis to the event, to the progression kind of thing. And another regression is Poisson regression, which is very common nowadays, which is modeling of counting numbers, that ordinal numbers, not ordinal, sorry, this is discrete count data, where you are counting the number of subjects. You want to predict number of patient will be affected by, you want to predict number of subjects affected by the COVID pandemic. How many people will get affected if we will do the lockdown or if we will not do the lockdown, that kind of prediction if you want to do based on some other factors. So you have to have a Poisson regression, where your dependent variable will be a discrete variable, the number of times women gave birth over a certain period of time. So these are the some of the example by which you can understand, okay. So I'm moving to the next. For ordinal, yes, for ordinal you have to use multinomial regression. Just like logistic regression is the extension of logistic regression, and which is known as multinomial regression. For ordinal, if you have ordinal variable, let's say I want to predict the pain, and which is having mild, moderate, and severe, okay. Okay, so let's move to the next slide and talk about the linear regression. So as I explained, this is the equation of linear. Earlier, we used to write it y is equal to mx plus c. This is written in some mathematical form because almost all kind of software, they give output in terms of beta. So betas are nothing but the regression coefficients. What are beta? Regression coefficient. Okay. So these betas are regression coefficients, and error term is the component, which is the residual term. So why is your dependent variable? Beta 0 is the population intercept, and beta 1 is the slope coefficient. So these are the linear component basically. X is your independent variable, and error term which we are going to quantify. Now, this is when we are talking about when we have only one variable to predict y, okay? But what happened in general? We cannot say just only one variable is associated, or it is affecting y. Let's say for the COVID pandemic, there could be number of factors, okay? Whether a person is vaccinated or not, whether a person is going out for the work or not, let's say male, female, and whether the person is having comorbidity or not. A number of factors can affect this thing, that the person is going to get affected by the COVID or not. So this is ordinal. uh, so now what if we have number of factors with this, which we have to include, that is known as multivariable regression, multivariable linear regression. Okay, now here most of the time I think people get confused, but this is the thing which you have to remember from today onwards, that it is not multivariate. Please remember and see the difference between multivariate and multivariable. Very, very carefully you have to understand this. So multivariate, when you are saying, that means you have lots of y's. Y means dependent variable. If you are writing multivariable, people will understand, those who are reviewing your manuscript or the research paper or thesis, they will say you have lot of dependent variable. But it is a multivariable linear regression. That means you have lot of independent variables and one dependent variable. Okay, so this is known as multivariable linear regression. So what happened here, this y is equal to a plus b1 x1. So as per your dependent variable, your regression coefficients will increase. For each and every independent variable, one regression coefficient will be calculated for the model. You can have n number of independent variables in the model. Okay, so let's say I am collecting information, number of information, let's say 100 independent variable, and interested to know couple of variables which is significantly affecting y, very significantly. Okay, not only clinically, but what, somebody is saying, please repeat the multivariable regression. So what I am saying, I'm repeating one more time. Multivariate linear regression, if you are writing, that says that you are having lot of y's, that means lot of dependent variables. So don't write it if you are using multivariable regression. So multivariable means you are having lot of independent variables, but single dependent. So you want to predict one dependent variable with the help of lot of independent variables. But if you are writing multivariable, which is an advanced topic of linear regression, which where we apply generalized linear model and other kind of thing, that we are not covering here. But just to understand the difference is y has to be 1 in multivariable linear regression, and in multivariate you have to have lots of y. Okay, so now for example, now this can be the same kind of, could be same kind of relationship. You can write your predictive model or regression equation in the same format, even if you are changing your y. Okay, so let me give you two examples before moving to the next slide. If my y is to find out the yield of a crop. Okay, so yield of a crop, how we will measure it, is in a quantitative way, in kilograms or in quintals, right? I'm doing some agriculture experiment, and we want to measure the yield of a crop in different plots, different types of plots or different types of things. So let's say wheat crop, or maybe nowadays people are not having this gluten diet. So let's talk about the millets now. This is declared as a millet year, right? Everybody should know that this year is declared as a millet year. So we are growing some millet, little millet, let's say, and we want to see what is the yield of this. So we want to predict the yield of a millet. What are the factors which is affecting to grow this? And what are the factors which can negatively affect or which can be positively affect? So just like correlation, regression coefficients or betas. So generally A here, which is represented A can be written as beta 0 or B0. All has to be B. So when you will measure it, your software will give beta 0, beta 1, beta 2, and beta n. So these are the regression coefficients. Okay. So I want to predict the yield of a millet. Okay, a different kind of millet. So what are the factors which is affecting to grow this? So one factor can be the variety, what variety you are choosing. One factor can be the irrigation which we are giving. Another factor can be the soil pH, and then climate, weather, temperature, many things. Now, out of this, we want to assess what are the really significant factors. I'm repeating it again, significant factors which is affecting. So if you are putting in the model n number of factors, by running the analysis, you will end up with the 4, 5, or maybe the 6, 7, or maybe only 2 factors, which is statistically and significant and significantly contributing, affecting the y, okay, yield of a crop. So it can be positive, it can be negative. So you might get the positive sign, you might get the negative sign. So positive sign means what? That it is affecting positively to the y. And if you are getting negative sign here, that means it is showing that x2 factor is affecting negatively on y. So you can reduce your things by so this is a prediction, you can think that what you need to improve on if you are getting negative marks, and if you are getting positive marks, that means that is your strength. So this is simple, you can find out your strength and weaknesses, okay, through this predictive modeling. Now, dependent variable can be of any type. Now, if y is, let's say, a type of disease, if I'm saying type 2 diabetes, we want to predict whether a person is going to have the type 2 diabetes or not. Yes and no. So my y variable, and what are the factors which is affecting diabetes? Okay, so my y variable is what? Dichotomous variable, binary variable, where I'm collecting information that whether a person is diabetic or not. This is like case and control. Okay, so case and control means what? Cases and controls those who are suffering with the diabetes and those who are not. What are the factors affecting it? So x independent variable can be of different types. That means the age of a person, whether person is having other type of problem, what is the physical activity, physically active, one person is physically active or not, what is the dietary pattern, it's a vegetarian, non-vegetarian, or some other foods are being taken, it is home cooked food, it is like family history of diabetes. The number of factors are there which you can include in the model, and can find out very important factor which can affect the diabetes. So where your y is yes and no, or case and controls, to find out the risk factors of diabetes, what you can do, you can apply logistic regression here. So it will be known as logistic multivariable regression instead of linear regression. Okay, yeah, people are writing genetic, lifestyle, age, family, yes, any type of number of things you can collect, but it is suggested that instead of having quantity, you should have quality data. Always remember, because if you are collecting lot of information here, what will happen? You might lose the quality of the data. So do the literature search, that what people are quoting, and based on your experience also you can include some of the factors, but take a wise decision for collecting all independent variables, and try to find out what are the most probable and significant variables which can affect the variable. So in this case, if y is your dichotomous variable, you have to apply logistic regression. So now when you have to talk multivariable, if you are just trying to find out relationship between y and x, that's the only one variable. It is known as univariate regression. When you are including more than one variable in the equation, it is known as multivariable linear regression. Okay, so simple linear regression, This is one of the objective to predict a person's score, or maybe you can say the quantitative variable on the as a dependent variable from the knowledge of their score as an independent variable. So it is also used to examine the degree of linear relationship between an independent variable and dependent variable. Now, when you have to apply, and what are the assumption when you can apply the linear regression? That is very important. What people do, they get the data, they directly put in the software and analyze, and if they are getting significant p-value, they report it. But they don't think the like whether their data is appropriate enough to apply linear regression or not. So for that, you first need to check assumptions before going to apply it. For any statistical method, every statistical method is having some kind of assumption behind it. First, you need to check, and then you should go with the thing. So what are the some assumptions of regression, especially the linear regression? Dependent variable has to be continuous, first very important thing to determine whether we are applying linear or not. Now this dependent variable has to be continuous, whether this continuous variable is having linear pattern or non-linear pattern. That will determine whether you have to apply polynomial or non-linear regression or linear regression. So that we are going to see in our hands-on. The independent observations, that means how do I avoid violating the assumptions. So you have to check that all the observation are independent of each other. Independent means there is no connection in between these two observations. Okay, so linear relationship, we can plot the scatter plot to see the relationship, or we can what we can do to find out the linear relationship. Yes, definitely plot and some other criteria, curve linear, and we can find out the r square to know this. We are going to see in subsequent slides in detail about the each and every assumptions. The fourth one is homoscedasticity. This is the error term that does not vary much as per the value of predictor variable changes. So don't worry about these terms. If you are not getting these terms, I have slides in detail. And the fifth assumption is you should not have too many significant outliers. Okay, otherwise that is going to create spoil your result relationship. Okay. Okay, people are saying, madam, go slow, but I have a lot of slides and I was thinking that I have to complete it by 7 so that I can uh, go on the demonstration part. But still I'll try to be slow. So first assumption is linearity. So you have to find out whether x and y are linearly associated. There is a linear relationship. So these are the scattered plot. Scattered plot, that means plotted on x-axis and y-axis. In one axis, you have to take x, and other axis, you have to take y and c. So in the first graph, as you can see, there is a positive association. In the second graph, it is showing negative association. But in the third one, it is saying that there is not at all a linear relationship. So in that case, you cannot apply the linear regression. Instead, what you have to do, you have to apply non-linear regression. Okay, curvilinear, polynomials, different kind of. So what is linear? What determines linear? So remember this is y is equal to mx plus c. As I told you, these things you people have already studied about the this line of equation in class 10th. So this is the thing where you have linear regression, and what was b? B was the intercept, and m was the slope of a line. How we define? If this is a linear line which we are plotting on the graph, so this thing which is just only the intercept b, and m is the slope. Okay, that you can determine from the angle. If you are measuring some angle, you can determine the slope. So based on this concept, we are trying to find out the value of m and b and predict y with the help of our observation, which is x. Now in the software, because we are going to use SPSS software. Okay, so when we are using SPSS software, how we can determine the linear assumption? By doing the PP plot. Okay, so PP plot, by doing the PP plot, if your all the observations are very close, generally they are very close, there is not much variation, okay, then you can say that linear assumption is met. And the next is no significant outlier, second assumption. So how to find out the significant outlier? So one thing, but sometimes, by seeing from our eye, it is very difficult to capture and decide whether this particular point is outlier or not. Like in the example we can give, we can write anything, I have made like this, that all points are near to that particular line, but one point is here and there. But you may have more outliers, and it will be difficult to find out whether this is outlier or not from the scatter plot. So what is the process to find out the outlier? Anybody knows how to find out the outliers? No? Box plot. Have you heard about the box plot? Whisker box plot? Yes, somebody is writing. Dr. Namrata is writing. Yeah. So box plot is the best way to find out whether outliers or not. So box and whisker plot. What are this box and whisker plot? This is box plot. It looks like box. It is a very good way of finding many things. It is also known as 5-number summary plot. Why 5-number summary? Because it gives you minimum and maximum. It gives you central tendency of a data, that is median. It gives you the variation, that means spread of the data, which is lower quartile and upper quartile or interquartile range. And these two lines outside the box are whiskers. If these two lines are equal outside the box, that means your data is normally distributed. If any of the line is smaller than the other one, that means your data is skewed. So see, lot of information you are going to get. And we say, when we were studying in the 9th and 10th class, we used to study about the histogram. So this is the smartphone, the histogram. To find out the spread and normal distribution is the Nokia wala 1100 phone. Now box plot has come, which is a smartphone, which is giving you a lot of things in one go. Okay. So somebody is saying it is explained by Anup sir. We can leave it, but I want to say about the outliers only. I'm not going to explain the whisker plot. So this is the thing, how you can find out. When you are plotting this graph, the software will give you some outline in terms of the circles, or maybe in terms of the asterisk sign. And outliers can be of any side. That means on the left hand side of the graph, or maybe out. And there can be number of outliers. How to find out, what we have to do? We have to take a smart decision. If it is a clinical trial, you cannot outrightly remove all the outliers. You have to take ethical approval for this, and then only you can remove these outliers and then analyze, because outliers are generally creating troubles and shifting your central tendency here and there and spoiling your results. But even then, it is not recommended that if you have got the outliers, you can remove it. But yes, if it is the case, this is extreme outliers, you cannot expect this frequency, but because of something happened and this highly extremely observations are coming, then you have to remove it and then analyze it. Okay. So how to find out? There is a one method, tucky fences. How you can find out? You have to find out quartile 1 and interquartile range, and put this formula. If any of the observation is going below this range, that means you have outlier at the left hand side. And you have to find out upper quartile, which is Q3 plus 1.5 into interquartile range. Then you can find out. And what is interquartile range? It is nothing but the difference between upper quartile and lower quartile. Okay. And then if anything is going beyond that, that means you have outlier on the higher side. Extreme values are there. and based on that you can take decision whether you have to remove it or not. As I told you, if it's a clinical trial and you are doing prediction, then you have to go through the some system and process. If it is a observational, you have to see the expert opinion and literature side, and then you can remove it. But the reason has to be very genuine. Okay, so this is the thing. Then the next assumption is homoscedasticity. So again, first thing is every time you are looking for the scattered plot to find out this assumption. As you can see in two of the first two scattered plot shows the heteroscedasticity. What is heteroscedasticity? It is showing you that variation. This is related with the residual which we are getting. Residual means predicted value and the observed value. There is a too much difference in somewhere, and there is somewhere there is no difference. So this kind of curvature, if you are getting in residual plots, there is a heterogeneity, and somewhere there is a, if there is nothing like this, that means you have homoscedasticity. So one more example, that this is the regression line and this kind of scatter plot you are getting. That means somewhere you are having very low variability and somewhere you are having very large variability. So what is this large variability? That means somewhere predicted values are too much as compared to the observed value, and somewhere there is very small variability. In that case, there is a heteroscedasticity, and you should be very aware about this. Then you cannot, because this criteria is not matching, you cannot apply simple linear regression in your data set. So one more, how to do this, how to find out homoscedasticity in SPSS. So we have to plot. Again, we have not only see the scatter plot like this. What we have to do, we have to plot another plot with the, not with the X and Y. This is not the plot. This is looking like scatter plot, but this is not between the X and Y. It is between the standard predicted value and the residuals. Okay, so for assessing the homoscedasticity, it's a difficult name to say. Again and again, I have to say, I was practicing it to say correctly. So homoscedasticity is, if you can see in the first plot, you can see there is a homoscedasticity, but in the second one, we cannot see homoscedasticity, because somewhere if we draw the line, one line kind of thing, we can see in both the side equal number of average. If we take the distance from the line, it is almost equal on the both side. But here, if we draw any line on any type of regression, we cannot see this line if we draw in this graph. So if this is the case, you have to say that homoscedasticity condition is not met, and then you cannot apply the linear regression. But this is the case, first one, that means you can apply it. Now the last assumption of linear regression is multicollinearity. Okay, so multicollinearity means it refers to when your predictor variables are highly correlated with each other. Predictor variables means your independent variables, by which you are going to predict the dependent variable. Okay, if they are highly correlated with each other, so that this is going to happen when it is possible, when you are having lot of independent variables. If you are just using one variable, then multicollinearity will not work. But if you are including lot of independent variables, then you have to check for multicollinearity for them. If it present, if you think it present, what will happen? It won't be able to accurately associate the variance of the outcome, which will lead to incorrect inferences or incorrect references. So only relevant for the multilinear regression, which has multiple predictor variable that I have already explained. So how to find out this multicollinearity? We can find out by the correlation coefficient. If correlation coefficient very high between the predictor variables, remember, we are not talking about the relationship between X and Y. We are talking a relationship between X1 and X2, X1 and X3, X1 and X4, X3 and X4. So that we have to check through the correlation matrix, right? And then we have to see if there is a multicollinearity. Then we have to enter any of the variable in the model. We cannot put the same two variables if they are highly correlated. Highly means 0.8 or higher, then you have to just see. And also there is one criteria, I just remember, let me complete this first. So multicollinearity, one more, in SPSS there is a one variable, one coefficient, variance inflation factor, okay, VIF. That value you have to check in your output. If it is below 10, then you can say multicollinearity is not existing, and then we can put these two variables together in the model, or all variable in the model. But generally what we take as a statistician, we try to find out, we try to take to get a better prediction and predictive model. If we are considering below 5, don't go more than 5. But this is the criteria which is given in the literature. Generally we say below 10, but we consider below 5. Okay, so I want to tell you one more condition here with the linear regression. That is, if other than the homoscedasticity, multicollinearity, and other thing, what was that I was thinking that I will say, and now it is not coming in my mind, but it will come when I will be explaining. So one more thing was there, that what you have to do. Yes, got it. So if you are including two variables in the model together, and one is used to find out the other variable. Now let me explain one thing. If we are including two variables, and one is used to define another variable, and let's say one is composite variable and one is independent variable, you cannot include both in the model at the same time. For example, if I am having height of the child, okay, and I am using BMI. So we cannot put these two independent variable in the model to predict something, because height is being used to find out the BMI. Because BMI, what is the formula for BMI? It's weight upon height square. So you cannot, either you have to put BMI only in the model, or you have to put height in the model, or weight. Height or weight separately you can put, or you can put just only the BMI. So that you have to see, if you cannot put the composite variable in the model with the original variable which you have used. You have to use only one, otherwise your prediction is going to be wrong. So that is the thing. Okay, let me see the chat. Ma'am, what should we do when we found that there is multicollinearity? When we found, simply we found multicollinearity between x variable x1 and x3, then you have to take only one variable into the model. We'll see in the example, don't worry about it. Yeah, so let's move to the other. Yeah, next slide. So no relation versus strong relationship. This is simple regression thing between fat intake and cholesterol, if we are finding out the relationship. And this kind of scatter plot is coming, that we cannot predict blood cholesterol with the help of fat intake. But if we are getting the second kind of graph, that we can predict the blood cholesterol based on the fat intake of a person. Okay, so that depends on what kind of how we are getting it, slopey. And so from this graph we want to say that your linear line should not be the parallel of the independent variable line x-axis. It should have some slope, then only you can predict. So type of regression method in SPSS, which we are going to start now, SPSS session. So before going to the hands-on, I want to highlight some of the methods. So when we because we have decided your dependent variable, independent variables, dependent variable and independent variables. I am saying variables means we are having a lot of independent variables. Now, other than that, in SPSS on any of the software, like I am using SAS in my organization, which is a programming language software. Nowadays, people are using R also. That is also programming language software. Beautiful software. R is freely available, but in some criteria, because we are working on the clinical trials, we have to use SAS, statistical analysis software. But any of the software which you are using, they will ask what method you are applying to find out this regression. So inside that also regression, there are some methods which we are going to, how we are going to select. There is a stepwise method, there's a backward selection, there's a forward selection. So these are the number of methods. So let's understand one by one. So one of the methods is stepwise selection. So what is this stepwise selection? Is a variable selection method. How you're going to select method, because you have number of independent variables now. So this is an automated method which is generated, which is created inside the software, that makes it easy to apply, very easy to apply in most of the statistical packages. You have to just mention method equal to stepwise. Okay, so that is when you are doing programming. Here we have to select, because SPSS gives you just only pop-up things, and you have to select from the multiple choice thing. What it does, it improves model generalizability. What it means, model generalizability, because automated system is there, number of simulations software using inside, and it is giving you the answer. It also yields a simple model that is easy to interpret. It will not give you very complicated model, very simple. But what is the like cons of this? These are the pros, but cons is it does not consider all possible combination of potential predictor, because it's a machine, it's a system. It will just do the mathematics kind of thing, and it will give you the model. But as a clinician, what is your intake? You want that, okay, there is a like moderate kind of relationship between x and one of the x and y. So but that has to go in the model. Even then software is saying, no, we have to remove that particular variable. But clinically, so statistically, software is saying it should not go into the model. But as a clinician, or as an investigator, or as a researcher, you have to take a call. No, this is a very important factor that has to go into the model. Then if you are using stepwise, you are going to lose that information. So in that case, you should not use stepwise selection. Otherwise, so let's understand the other second method is forward stepwise selection. So forward stepwise selection, how it works, it begins with a model that contains no variable. So first, it will just say y is equal to a. That means y is equal to a plus bx. So it will create a model with a, which is known as null model, y is equal to a. Then it will start putting variable one by one. Okay, so y is equal to a plus bx1, then y is equal to a plus bx2, or then y is equal to a plus bx1 b2 x2, or that kind of all possible. So then start adding most significant variables. So inside these procedure will be happening that it will be finding out univariate variable which you will not be able to see. That thing is going inside that, and it will take most significant variable one after the other and compile them and give you the one significant statistical model. So until a pre-specified stopping rule is reached, so you can specify the stopping rule, or you that can be done default by default of the software. So what is stopping rule means? If you are saying no, statistically significant or variable, so significance you can define here. If you know about the significance, what is p value? What do you understand by the p value? P value p value has to be less than 0.05. We know this defines a statistical significance, right? So yeah, statistical significance it defines. Yes. So what we are saying, I'm not going to detail, otherwise my today's session is going to over. I can define that later. So p value, so by default software takes the value of 0.05, as everybody is saying, level of significance. Yes, correctly. So we can define stopping rule because, in some of the area in metabolic studies, some biomarkers, in some cases, uh, we cannot reach to this 0.05. So we can define it 0.20. Okay, we are saying we will consider the significance if something is reached by the 20% significance. Then you just include that into the model and then see. So you can define in the software the stopping rule. Okay, if this is reaching here, then you can see. So that is also available. So the next slide says how to determine forward selection. Okay, first thing, determine most significant variable. So most significant variable can be picked up from the smallest p-value, and also it provides the highest increase in R square. So what is R square? That is also very important to understand. As I was telling you, you have to define what is your R square value with the model. If you are not giving this R square, your model is not validated. So this is a type of criteria or outcome by which your model, which you are proposing to the scientific community for prediction purposes, if it is not having the R square value, your model is not validated, and it has to have the highest R value, the higher R value. Okay, then you can say that it is. I'm going to, I think I have one slide on R square as well. Now choosing the stopping rule, how when all remaining variable to consider have the p-value larger or the some specified threshold value. That means, as I told you, that you can add into model. By default, it takes 0.05, but you can define a threshold value, which is 0.20 or something else. Then another method is backward stepwise selection. So these are the three methods. One is stepwise, then another is forward, and another is backward. So backward, what it gives, backward means it include all the variables first time. It start with the including all variables in one model. Okay, and then try reducing one by one. So it is called as the full model. While forward stepwise selection method, what it was doing, it was starting with a null model and then entering one by one variable in the model. But in backward, what it is doing, it is including all the variables in the model which you have put, and then removing one by one with the least significant variable with the same criteria of p-value or threshold value which you are defining for stopping rule. Okay, now out of them, stepwise, backward and forward, which one you have to use? So there is one criteria which is written in the green lines, that forward stepwise selection can be used when number of variables under consideration, that means you are putting in the model, okay, is very large. Number of variables is very large, even larger than the sample size. Let's say I have collected data for 100 subjects and you have 150 variables. In that case, forward selection method can be work. Otherwise, if you have 100 observations and you have just only 5-6 variables, then backward method may work for this purpose. So as I was telling you about the R square variation explained, it is the correlation between observed and predicted value, and it is the proportion of variance in the dependent variable which can be predicted from the independent variable, and close to 1 is always good. R square is nothing but the correlation square, and correlation between what? Observed value and predicted value. So it, because this is now correlation square, so always you will have positive value, you will not get the negative value because of this square. But close to 1, always value will be that means you are having a very good model. So this is the slide after my, I have to just show interpretation after showing you the data. So let me go back. Somebody saying, is audio okay for all? Am I audible to everyone, or it is just only Dev Jani? Yes, everybody is saying yes. Okay, okay, okay. So I am stopping here, and now let's start the hands-on. So let's start with the linear regression. Yeah, somebody is asking about the enter method. That enter method is the climax, which you are going to see during the hands-on. So let me share my screen again. Can you see the screen again? There is one more method. People are very smart. They know, they have done the homework. So there's one more method, that is enter method, when we have to use. That I'll do during the hands-on.
Excuse me,
Yes.
Dr. Shukla here. And your
Yes, sir.
screen is a little that you have to increase that one.
So let me stop share and share it again.
Please share again.
Where is this? I don't know how I'm getting this screen. Let me close this and then open that file again. Yeah, this is in this folder. Because I opened that file for so long. I'm going to share it in. Yeah. Here you go. I hope it is visible now. Please confirm.
Yeah, it is visible.
So you people have got exposure of SPSS. So I'm not going to explain that there are two windows, variable and
No, no,
data view.
that is not
Yeah.
required, ma'am. That is required.
Yeah.
You are clear.
So let's go to the variable view and see how many variables we are having and what are the things here. So we have a small data set, okay, and we have one gender variable which is defined by female. Why it is defined by female? Because we are female centric. I love this statement. So we have defined one for female. This is nominal variable. You can define any type of, like I have defined one for female and zero for male. And then we have race. I don't know why it is having the decimal points. Okay. And then we have socioeconomic status, low, middle, and high. And we have type of school, whether a student is studying in public or private school. Okay. And then we have program, in which program they are studying. That means general, academic, or vocational training. And then we have marks of the student in reading, writing, mathematics, science, and social science, social studies course. Okay, so let me go to this data set. As you can see here, reading marks, writing marks in exam, mathematics marks, and science marks, and social science marks. Okay, social science marks, why it is in the ordinal? I have to change it to the scale, because this is also scale. That is very important to define what type of variable you have. Now for applying the regression, what you have to do? You have to linear regression. We are talking about linear regression. So in linear regression, what you have to do? One thing, what is your predicted variable? So let's say I want to find out that whether the student, how many student will go for the NEET exam, and I want to predict that science marks, okay, based on mathematics, writing, and reading skill, even social science. Let's say this is a 10th class marks of this student, 10th class student marks. Okay, so I have to go to analyze and go to regression. Okay, now as our y variable is what? Y variable is a numeric variable. Then we have to go to linear regression. Okay, I'm going here and this window will pop up. People are requesting to share this data as well. I'll share, no problem. So this, what is happening here with the linear regression? Linear regression, this is asking for the dependent variable, independent variables. Okay, one dependent variable and some are the independent variables. Now, before putting in the model, what we have to see, before taking all the results, we have to see the assumptions. So we'll see one by one all the assumptions, they are going to met or not. Okay, so for this, our dependent variable, as I assume, the science score. Okay, and dependent variable can be some other variable. So we have to see one by one. And before this, what I started my talk, how I started my talk, it is with the correlation. So I'm canceling this here. You have to first see whether these marks are, though it is obvious that math, science, reading, and social science marks will be correlated with the science marks, but still these are the variables which is known. But sometimes when you are doing some different study, in clinical study, you don't know what could be the relationship. So what you have to do first, you have to do the graduation and then come to the post graduation, right? So let's check the graduation part. So for all continuous variable, you have to see the correlation. Correlation can be find out only with the numeric variables, and that is required. So we are trying to see the Pearson correlation. What is the, there are a number of methods. So Pearson and Spearman, if the normal distribution thing is not met criteria, then you have to find out the Spearman as well. So here we are considering, and if you have large number of observations based on the central limit theorem, we assume that this is approximately normally distributed, and we are trying to find out correlation coefficient. So in the option, you will get the means and standard deviation, but we are not looking for this. We are looking for the correlation matrix. Can you see the output window? Or I have to share it again? Can you see the output window?
Ma'am, you have to open
Please
the output window
confirm.
you have to open the output window from sites.
Okay. Now can you see?
Yeah, it is coming.
So now output window, if you can see. So here we are getting correlation matrix. Okay. So reading score is associated with the, significantly associated with the writing score, because we are getting stars, and star, that means it is significant, highly significant at the 1% level of significance. Okay, so these things you have to see, and all the variables are associated with each other. And now for multicollinearity, what you have to see, your dependent variable is science, so just forget about the science, but you have to see the correlation between reading score and math score. It is not going beyond 8.8, 80%. Okay, so reading score with the social studies, it is also 0.6 to 1. The reading score with the writing score, it's also 0.6%, 60% around, because 597. Okay, so multicollinearity assumption is not met here. Are you getting my point? One thing we have seen just only multicollinearity among the independent variables that we have checked. Also, we check the whether correlation exists or not. The science score is correlated with all other scores. That means we pass the graduation exam and we can go with the postgraduate degree. So now I'm going to apply regression linear for seeing the other assumptions. Okay, so independent variables, if we see for the, let's say for math score, then we have to go to the plots for PP plot, which is the plot between residual and predicted variable. So what you have to do, you have to put the predicted variable in the x-axis and residual value ZRES, residual value in the y, and click on the normal probability plot and continue. Okay, and you have to go to statistics and click on the collinearity diagnostic. That also you can do. Yeah. Okay. And then click OK. So the major thing you can do here, you have to go see all the variables, not very much deviation, and that's how this assumption of linearity in math. Even if you see this graph, what you can do in double click on the scatter plot and put the regression line here, okay, and then see there is no heteroscedasticity, okay, equally almost, except one or two outliers. So that also can be seen. Outliers, if you can remove one of the outliers, it will be completely okay. But for one or two, we can just go with this. So all the criterias are matching, and then we can go with the regression analysis. So I'm going to include all my variables, not writing, let's say reading and social studies. And whether it depends on male and female or not. What all variables are included? These variables. Now, people were asking about what they were asking about the enter method. Now, in the last couple of slides, I explained the method. Inside the linear regression, again, there are method. Now I'm clicking here. If you are able to see, you can see stepwise, remove, backward, and forward, and enter. I have not explained the enter method. Why I have not explained? Because most of the time a statistician, and when you are well versed with the, like, you are expert in regression analysis, you would love to use this enter method, because you can use some literature, you can use some your sense and some other correlation regression things, and you can put the variables of your choice and see the all possible combination. Because in backward and stepwise and forward, what happened? Let me apply one of them. Let's say backward method. Okay, in all of the variables we can apply, let's say select all the variables except id cannot be a variable. Okay, I'm applying all the variables, and let's see what is happening here. Okay, and let me remove these assumptions now, because otherwise it is going to come again and again, these plots, and we don't want now. So cancel. Okay, we don't want the normal probability plot now. We are building the regression. Now here, when you are ready for the model, after checking all the assumption, don't put the linear diagnostics. Okay, linear diagnostic I have not covered. Now what we have done, we want the R squared change, descriptives, and 95% confidence intervals, very important. So you have to check all these. Okay, so let me go up. If you can see the output window here, you can find out this VIF factor, variance inflammation factor, as I explained in one of the slides. It is coming 1. It has to be less than 10, but I recommended it has to be less than 5. So that means this collinearity condition is also fulfilled. Okay, so that is less than 5. Yes, people are asking, dependent variable always continuous? For linear regression, yes, it has to be continuous, dependent variable always. Okay. If you are changing your dependent variable, it will be a logistic regression, which we are going to see the demonstration here also. So what we are going to use? Backward method. I'm clicking OK, and let's go to the output. So this is why descriptive statistics is very important, because what variable, what type of distribution and spread each and every variable, you have to give this beforehand. So this has to go in your table 1. Then only you can talk about the correlation and regression. So correlation is also coming with each and every variable, but we are not interested in correlation because we have seen that. Now let's go to this variable. Now can you see this variable entered or removed? So it is giving you the backward method, each and everything that you have entered all these variable, but variable removed by the software is social studies course. Okay, type of schools, so SES, socioeconomic status, type of program. These are variables are removed because it is according to that it is not found significant. Then if you go to the model summary, so it is presenting model 5 models, 1, 2, 3, 4, 5. 5 models it is presenting as per this model 1, which is using enter method. That means it is entering all your scores and giving you the results. Second, it is removing your social study and giving social study score and giving you model. It is removing type of school and giving you model, and rest of the variables are there. Okay, so let's see the model summary. Now you have to check this model summary, especially this R square, the first, second, and third column. Can you see this third column? R square value is coming around 55% everywhere. Can you see this? 55% R square value. So that means all the models are giving almost the same kind of variation explained, not very much. And that's how we prefer to have the enter method instead of these things. So let's go here and see. This is ANOVA, that model 1 is significant, 2 significant, 3 all are significant. But let's go and check here the coefficient. This is the important uh, table to see. Now here, first thing you have to jump on and see the significant value. The significant, okay? So significant value is what? Significant value, you have to check if you are getting the best model. It says if all value enter in the model have a significant value. Until unless clinically it is very important to have it in the model. Okay, so what you have to do, you are seeing like here social study score is not statistically significant, right? Then social economic status, it is not significant. Then type of school, it is not significant. Okay, that kind of thing. So based on this, what we apply the enter method. Now in the enter method, because enter method is what, the first model, rest is the backward, like it is removing. Like from the second one, social studies has gone, and then you can see the socioeconomic status and type of school is also not coming significant. Then it will remove one by one, and you can remove both. Okay, so what is happening, people are writing some, let okay, nothing related to this output. Yeah. So what we have to do, we have to use the enter method most of the time if you have got the technique in this. So because ultimately what you are looking for, you and the overall model, see homoscedasticity is also achieved here. So I'm going to analyze the same model based on the enter method, regression, linear regression. Where is linear? Yeah. And I'm going to use the enter method. This is the best method which I like. Okay. And in this, I will directly go to this coefficient table and see what all variables are not coming significant, and then we will remove. See, the regression coefficients are also very low, 0.04, and this is negative also. So let's remove all the variables. So here you can try all possible combination with the enter method. Okay, you can try all possible combination which is having. So now I am removing social studies, socioeconomic status, and type of school. Even type of program we can remove from the model. So regression, and what we have to do, we have to remove these. So what was the social economic status? Type of school was there. Let me see the p-value. Yes, type of school. we don't have to, and type of program we don't have to. Type of school, socioeconomics and social studies score. Yes. So I'm removing all these and running the same program again with the enter method. And let's see. So we have to go to the coefficient matrix here. Okay. And then you can see the p-value, each and everything is coming significant. So after putting number of variables, finally what we have got with the 1 2 3 4 5 variables, which is giving a completely significant model. Okay. Now what is the interpretation of this model? How you are going to interpret this model? So in this model, what you are going to, these are the beta. See, B is means beta, that means regression coefficients. So you have to write your regression equation something like this: 6.755 plus 0.278 into math score plus 0.239 into reading score minus 3.5 into female, or maybe you can write gender. Then you can write plus 1.39 into race, and then writing score plus 2.8. So what is the interpretation? That irrespective of all the variables, if we include that means if we have to say that irrespective of like holding all other variables constant, what is the value we can expect in the science marks? So science marks, what we are expecting, we're expecting 6.755. If maths marks is 0, reading score is 0, which is quite very rare in writing, it is 0, then what will be the value of science score? It is coming 6.75. Approximately you can say, because this is discrete variable marks, so you can say 7 marks one person can get if they are getting 0 in maths, reading, and this. Now if we have to define about the math score, so what it is saying here in the interpretation of this, that every increase in the science score, if the maths score is increasing by 0.27 unit, that means if it is increasing, that science score will increase by 1 unit. Similarly, the reading score, if reading score is increasing by 0.24, you can say in 2 decimal point, 0.24 by 1 unit, then science score will increase. Now what will happen? The female is getting this negative. What will be the interpretation for this? Is a dichotomous variable, binary variable, and we have given female to 1. So basically you want to interpret. So this shows that for 1 increase in the science marks, that means females will get less mark as compared to the male. That this regression is showing. This is, I'm not saying anything about it, but females are good at maths now that the science. So just for the lighter side, I'm also like mathematics person. So female, that means it is getting, we are getting 3.5 times. So we have to define 3.5 times female will get lesser marks as compared to the male in science, because it is negative sign. So wherever you are getting positive sign, what you have to do, you have to define, like race. For race, we have to see what race we have given and what was the reference category that we have to define. And then writing score is also positive. Okay. So that is the interpretation. Now I have given the interpretation based on taking just only social science and reading thing. So I want to rerun the model with the same interpretation so that when you see the slides, you can connect. So reading score, mathematics, female, I am removing race because this is of no use for the marks, and writing score also. So I'm putting just only few variables: maths, reading, and female. Maths, reading, female, and let me put the social science score as well and rerun the model. Okay. So when we are running this model with the enter method, what we are getting? we are getting this. Okay, I want to include social science score beside that because this is clinically important. So you can give this. Now, interpretation, if we have to go, so I'm going back to this PPT and you can see how you have to write. Can you see this? So how you have to write your equation that you are predicting science score is of this type 12.325 plus 0. So this is equation. That's how you have to write it. Okay. And how you have to interpret that a 0.39 unit increase in science is predicted holding all others variable constant. Okay, in the maths. And for female, the predicted science score would be 2 point because it is coming here with these variables -2. It was coming earlier -3.5 something. So 2 points lower than the males as we coded female as 1. Okay, if we want to interpret, we have to code it differently and then interpret for the male. Okay, so that coefficient will get changed. It will be positive if you just change the coding. For social studies, 1 unit increase in the social score, we may expect approximately 0.5 unit. I think here I have to write something. I forget to write the math. Unit increase in science is predicted holding all other variables constant for maths. Yeah. So we can change the reference category. People are saying we can change the reference category here also and see this if this value changes. So for every unit increase in reading score, we expect 0.335 point in increase. So that is the interpretation. Now I'm going and showing you one of the example because time is running and we have to. Can you see the data again? I'm sharing one more screen of output. So let me go here and see. Can you see this data again of EGFR? This is medical data. Is it visible? So yes, they can see. Good. So one person is asking a question. Let me quickly take it by Dr. Sujal. Sometimes what happen is only constant left. Other variables are removed in the last model. That's how I'm saying that don't use the backward method. Always try see the correlation matrix and literature, and based on that, try to make your own combination. Try different combination by doing entering the model in this. It is taking a lot of time, but it will work because when you put in the backward, definitely just only constant term left. Okay. So yeah, so this is another data which is the real data. We may or may not get the significant results from one of my study, which is on the EGFR uh, thing of lung cancer patient. Cancer patient data is there. Okay, where you can see the number of variables are there, but we are going to work on some like comorbidity, morphology, tissue type, what is a site, alcohol history, smoking history, family history. Then these are the targeted therapies, and our outcome variables are progression-free survival and outcome overall survival. Then chemotherapies.
Excuse me,
Yes.
ma'am. Dr. Shukla here. Ma'am, please
Yes.
show your data window. No? This is output window.
Okay. I have shared both the windows.
Just
So
click
I
on
think.
it will be so it will be visible for all.
Okay.
In spaces only.
Now it
The
is
screen
visible.
still output
It
window
is
is open.
visible now.
Still output window. Yeah.
Okay, so I
Not,
have to
not the
stop sharing and then share only the first data, and then I'll go to the output. That will work. Is that okay now? I shared both the screen at the same time. So is it okay now?
Yeah, it's coming.
It's visible now, the data?
Again, yeah, it's not green.
It's
Yes,
visible,
sir.
right?
Yeah.
Yeah. So in this, lot of variables are there where we have observed the smoking history and these things which I am going to tell. Now, here let's apply logistic regression. Okay. So logistic regression can be applied when we have binary variable, right? So in binary variable, what we have to do? So let me check this outcome variable is having lot of variables alive with stable disease, alive with progression, death and loss to follow up. No, we want outcome variable as a, yeah, censored or death. So we have outcome variable, binary variable. We have to have binary variable. Okay. Okay, so I'm going to share output window and there I'm going to apply this data. Okay. No, first let me do this because output window will not be there with a different data set. So for applying logistic regression, what you have to do? We have to go to binary logistic regression. We have also multinomial logistic if we have, ordinal data. For binary, here we have to go and this window will pop up. Can you see this window? Which is again asking dependent variable, and instead of independent variable, it is asking you the covariates. It's the same kind. And again, the methods are also same backward. And then why it is conditional? Because if you are using match case control study, then you can use these variables. Otherwise, always remember enter method is the best. You have to try your own combination and permutations and about according to the literature and your research. So dependent variable, what we are thinking first to take this as a binary variable. Now we want to find out whether this outcome of this cancer subject, it depends on the gender of a variable of a person, or maybe the age of a person. So age, I am having two different types of age variable. One is continuous age and age as a category. So again, what variable you have to apply? Always it is recommended to have a continuous variable, because in that sense, what will happen? Sorry, this data I cannot share of this cancer because this is confidential. We cannot share, but definitely that math score data we can share. I can share it with you. So in the, like, whether you have to take age as a continuous variable or categorical variable, one thing, as I told you, always recommended to have a strong power, because when you make a continuous variable into categorical variable, you lose some power of the study. So if it is recommended and you want to see, no, this lung cancer, we want to see in the young people and elderly people, what is the difference, then definitely you can go with this. Okay. Otherwise, age has to be always in this form, continuous form. Then if we want to see whether it is also related with a person is having diabetes or hypertension, how it is impacting this death of a lung cancer subject, whether person was a smoker or not, whether person was alcoholic or not. So these things, like, it's not something after closing your eyes you're putting all the variable in the model. Then you will not end up with a good number of things. So you have to see that yes, these are the some good factors, but we want to check some other factors which information we have collected on. So death, our outcome is death or person is alive, whether he has got chemotherapy, whether he has got the radiation therapy, we have the radiation therapy, and whether the person has got the um, uh, uh, targeted therapy. Okay. So I think this chemo and radiation, as I remember, these are not a particular category, but this CT is chemotherapy and targeted therapy. So what are the factors which is affecting this? Okay. So let's put now here in the logistic regression, it is very important. If you have a categorical variable, you have to mention here. Okay. You have to mention in the category. Otherwise, it is going to consider as a continuous variable and your uh, values will be different, which is not correct. So I have gender variable as a categorical comorbidity where I have, I guess, hypertension, diabetes, and other factors. So we have to put, you can select all categorical variable in one go or one by one you can put. Now here, automatically by default, reference category is the last category. That means if you have defined 1, 2, 3, then third will be the reference category. You can change it by doing the first and click on change for these variables. Or you can keep like this only last category. Okay. So that depends on you, what reference category, what you want to interpret for. Okay. So you want to interpret, if I have coded 0, 1 for the smokers, then I want to interpret for 1. Then last category will not work in that case. Okay. So let me go back and check what I have coded here. So for smoking, I have coded as positive and negative. Sorry. So that means yes and no. So negative is 2. So I am okay with the reference category with negative because I want to interpret about the positive. That means those who are a smoker, what is the criteria? So I'll go with the last category only. I have to put this category again, all categorical variables. Okay. And then continue. Now, 95% confidence interval is very important to report with all your beta values and other things. So for this, you have to go to the option and click on 95% confidence interval. That means all beta is B. That means regression coefficient. We need 95% confidence interval. You can have the correlation also, but before applying that, you have to check the correlation matrix. So not required here. And then this is the enter method. Let's see how many are coming significant. So I'm going to the output window and then see. I hope you can see the output window. Now Lalit is asking how to take reference category. So how reference category, that means reference category, you are taking this as a reference and interpreting for the other categories. So if I am taking male as a reference, I will be able to interpret about the females. Okay, if I am taking reference category as a diabetes, I reference I'm interpreting about let's say hypertension is another category that you have to decide. Okay? And that's how basis you can go or you can change the reference category. So for what you want to define. So now here in the logistic regression again, it will be told that what internal value it is taking. The death is the outcome variable is coded as 1 and censored as 0. Okay. The comorbidities value. Now here we have different categories. It will give you all kind of information in this. So we are having diabetes, hypertension, and other comorbidity, and those who are not having. So 141 people are not having any comorbidities. 33 are having different which we are not talking about, but as literature, because we want to highlight on the diabetes and hypertension, so that we have taken. Okay, so nil category can be a reference category. As you can see in this, there was some network issue. Am I audible now? Am I audible now? Yes, people are saying now. Yes, I'm audible. No, some are saying yes, some are saying no. Is the screen visible?
Yeah, screen is visible, ma'am,
Spread.
but little audio network issue is there. Little audio problem.
Okay.
Now it's
So
okay.
this is okay now.
Yeah, yeah.
So because I was connected through my mobile, because sometimes when electricity go to my Wi-Fi get disconnected with this. Okay. So I was talking about the on this screen, which you can see that reference category here is nil. What they have considered nil, because all the values in parameter coding is zero and that. Okay. So in one case, others is there in one, hypertension, there is one, and then diabetes one. So the reference category is nil here. Based on those who are not having any comorbidity, what will be the implication for diabetes? What will be the implication of hypertension? What will be implication if they are having some other kind of morbidity that we want to assess? Okay. So chemotherapy given or not given, smoker is whether the person is smoker or not smoker, alcoholic, family history is there or not, TKI is given or not, then male and female. So here you can see that wherever you are getting this thing, that means this is given. Female is a reference category. We are talking about the male because most of the time literature says the lung cancer is identified on the male male person. As you can see in the data set also, the frequency, what it says more males are there with the lung cancer, 124 out of 95 females. So now you have to go down, and as somebody was pointing out correctly, that variable in the equation is just only the constant, and variable not in the equation is coming like this, because we have put lot of information in one go, right? We have to choose wisely, like what are the variables which we have to take into account and put. Like smoking is significantly associated with the with what, smoking, lung cancer. But alcohol, though it is not significantly associated, but it is coming something 3.36 times. So let's go down in the enter method. Variable in the equation, when we put all equation, what we are seeing, these are the significant values which we are getting, right? And then exp beta, what is exp beta? It is giving you with the logistic regression, we get the odds ratio, not the relative risk. What is the difference between odds ratio and relative risk? When you are doing a retrospective study, you will be able to find out odds ratio only. Relative risk can be find out with the prospective study. Okay. So with the logistic regression, we will be able to find out odds ratio. Okay. So this exponential beta, okay, this is nothing but the odds ratio with the 95% confidence interval. So if odds ratio is more than 1, that means it is giving you some dangerous sign. If odds ratio is less than 1, that means it is a protective site, protective kind of thing. And if odds ratio is exactly equal to 1, that means there is no association. So you don't have to take that into account in the interpretation part. Now let's see, because we find the comorbidity definitely is associated, can definitely be associated with the death. So we have to keep into our equation. Okay. Age is also a factor which can affect the death. So we'll keep it in, and that is coming little bit closer to the significance. Gender we can omit because it is not giving this thing. So gender we will remove from here. Then smokers, definitely we have to take, because we have to adjust it for the smokers and alcohol. So let's say alcohol if we are removing, and then see what is happening. Family history, why it is coming, I don't know. And then TKI, targeted therapy, and chemotherapy. So let's do something with this. Yeah, so cohort study, with the cohort study and prospective studies, clinical trial, we can find out the ratios. But with the secondary data like this, we can not do. So what we are going to remove, we are going to remove this gender variable. Let's remove the alcohol. And what else? Yeah, let's try with these. We are removing just only two variables, and let's see. Go to the equation, variables in the equation, and see the values if something is changing. So nothing is changing. Family history is not coming. So lung cancer is not at all associated with the family history. If somebody is having family history, this is not required that the other person will get, the younger generation will get it. Okay, this is altogether how you're thinking. But smoking has come significant. Comorbidity is not. So if comorbidity is not is associated with lung cancer, let's remove this also. So here I'm going to remove now the comorbidity and family history, and then see how it is coming. So these combination permutation you have to try. So now here you can see with the chemotherapy, it has come what? Somewhat significant. But targeted therapy is not coming significant. Smoker has come the significant. Age we have to adjust for, so that will be here only. Adjusted equation, we can say. So let's say this is our final model which we want to give. Okay. Or we may also, if we are interested, remove the TKI and then see. So let's do one more time and remove the targeted therapy and see how the model is coming up. So in this model now, see, almost all variables are coming significant. We have just smokers and chemotherapy. But this is not the thing which we should take. We have to have some more things into it. Like we can also include, this is just, I'm giving a glimpse. We have to include, let's say, tumor size is there. And even then severity of the disease, like whether a person was having, stage 1, stage 2, stage 3, because that also depend on the death, because that death is our outcome variable. So instead of taking just only this, let's just take the therapy, because it is having all type of therapies here. And then what else we can do? Yeah. And that comorbidity, because that I am thinking that clinically it is important, and then see. So let's interpret this model. Okay. Constant term is nothing, not very important. You can interpret it, but we are looking for just only the constant term interpretation is if everything is not there in the equation, what will be the null value? So somebody is not smoker, somebody is not taking any therapy, and somebody is not having any comorbidity, then the constant value is something this. So let's explain. Let me increase the size if I am able to. I don't know how to increase the size. Okay, I think you are, this is visible to all of you. So let's interpret this quickly. Okay, so time is, I have already crossed the time. So smoker, it is significant. So odds ratio is coming 2.03. So that means you have to say in our sample, we are saying those who are smokers are having 2 times of getting death with the lung cancer as compared to those who are not smokers, and which may range for the population from 1.1 to 3.78. Okay, so that means in our sample we have got 2 times, but population inference will be, it might range from 1.1 to 3.8. You can directly say. Now therapy, for therapy we can say that if a person, because odds ratio is less than 1, so it is protective. If somebody is getting any kind of therapy, what will happen, that is death rate is less. Okay, because this is, you have to interpret through 1 minus odds ratio. So in that case, whenever odds ratio is less than 1, you have to do 1 minus odds ratio. It is 1 minus 0.74. That means this is 26%. So there is, if somebody is getting any kind of therapy, 26% of the chances are increasing of survival. Okay, that is the interpretation. Then comorbidity, if somebody is having diabetes, they are having more, because this is going more than 1. Again, I think it got disconnected again. So hope interpretation is the thing which you are getting, and these are the things by which you can interpret. Okay. Now, if you have any question, because I have already taken a lot of time here. See, this is a totally different thing to explain the crude odds ratio and adjusted odds ratio. You have to adjust for some other variable, then you can find out crude odds ratio just only with the one variable which you are giving, univariate. Okay. I'm getting some good comments. Thank you so much for these comments. Time is very less. Like we can cover a lot of information, but yeah, with the limited time, we can do this only. I hope you enjoy this presentation. Thank you, everyone. And you can reach to me through Dr. Dharmendra if you want. He is having my email ID. And if you have any query, you can write to him and he will forward it to me. Thank you. Thank you, everyone.
Thank you, ma'am. Ma'am, can you hear me?
Yes, Dr. Dharmendra, I can hear.
Sorry. Actually, I don't know. My voice was not coming. So thank you
Yeah,
so
yeah.
much, ma'am, for your valuable and very interesting session. It was very interactive. I hope participants have enjoyed. Since we have very less time, so it's not possible to cover all this thing. But at least you have given some idea how they can go forward. So thank you so much, ma'am. Thank you all. Thank you,
Thank
participants.
you, everyone.
Thank you so much.
Thank you. Bye.